So before we start this next section, we're going to do a little review on scatter plots. So you guys did this back a few years ago in Algebra 1, Math 1. So go ahead and pause the video, and given this data, draw a scatter plot with the number of past papers being your x-coordinates and your exam grade being the y-coordinates. So here's our scatter plot. Again, make sure you label and scale your axes. This is a little different than everything we've done so far. Everything else we've done is one variable statistic, so we've always had something on the x-axis and then something like frequency on the y-axis. In this case, this is two variables. We're comparing the number of past papers taken to exam grades. So your x-coordinate is the past paper taken, your y-coordinate is the exam grade. Scatter plot, you just plot the points, and that's what this scatter plot look like for the data. So lesson 3.4, the last section from chapter 3, is introducing bivariate data. Again, everything we've talked about so far has been univariate or one variable data. Bivariate data is two variables. So you're comparing two things to see if there is a correlation between them. Your independent variable we always plot on the x-axis. Your dependent variable you plot on your y-axis. Independent, you're testing to see if the dependent variable depends on the independent variable. So does your exam grade depend on how many past papers you took? So when we're looking at scatter plots and bivariate data, we can talk about correlation. Correlation is how related the two variables are. And one thing that we talk about is the directionality of the correlation. So the first one would be positive correlation. So as your independent variable increases, so does your dependent variable. So it's going to have a positive looking slope, similar to the warm-up that we just did. The more exam grades they took, the more past papers they took, the higher their exam grade went. Correlation can be negative. So as your independent variable increases, your dependent variable decreases. So this would be like something, the more you study, as time increases on the study, the less you play video games. So your video game would decrease. And then no correlation, they're random, they're neither positive nor negative. We also talk about the strength of correlation in the next chapter. We're going to get more detailed in this. Right now we're just going to look kind of general. So strong correlation, where it's very obvious that they're related to each other. They're pretty linear. Moderate, you can see a trend, but it's not as good as something that's strong. And then weak or no correlation is very cloud-like. You can see there's kind of a general trend upwards, but not anything near moderate or strong. So then looking at these three scatter plots, describe the correlation using their strength and their directionality. So the first one here, I would say there's probably a strong positive correlation. Definitely positive, it's increasing. Strong, it's pretty linear. Maybe if we zoomed in, it would look a little bit more cloud-like, but I would say strong positive. Between a height in meters and your weight, usually the taller somebody is, the heavier they're going to weigh. There are other factors that go into place, but that is a good general trend. For part B, it's less linear than A, but it's still positive. So I would say a moderate positive correlation. The number of family members, the more family members someone has, we see a general trend that there's more pets, but that might not necessarily be true. And then the last one, it's negative. As the temperature increased, the number of days decreased, and I would say it's pretty strong. So I would say a strong negative correlation. As the temperature increased, the number of days, they don't tell us what, maybe you wore a coat, decreased. So here we have the number of schools and the number of restaurants in a town over a 40-year period. And we want to compare the number of schools as our independent variable compared to the number of restaurants as our dependent variable. So first draw a scatter plot. Describe the correlation between the two variables using strength and directionality, and then state whether you think one variable or one set of variables causes the other, and then possible reasonings why they increased. So here's our box and whisker plot. Again, make sure you label your axes. So x-axis was number of schools. I skipped up, started at 10, that's what the little zigzag means, remember, and then I went up by ones on my scale, and then my y-axis is number of restaurants. Again, I started at 20, and then I went up by 2s, and then just number of restaurants is x-coordinate, number of schools is x-coordinate, number of restaurants is y-coordinate, and then you create your scatter plot. So So if you haven't already done so, go ahead and pause the video and answer the rest of the questions. So describe the correlation, state whether you think one causes the other, and then state possible reasons for the increase. So for the correlation, there's definitely a strong positive correlation between the two. As the number of schools increases, the number of restaurants increases at a pretty steady rate. Whether or not one causes the other, I don't think that the number of schools increasing directly causes the number of restaurants to increase. I've never heard somebody say, oh, I'm going to build a new restaurant because they built a new school. There are probably other reasons why they both increased. For example, the population of the town increased. So when you talk about correlation, you can't necessarily say one caused the other. So that's a pretty good example. We talk about correlation versus causation. Right now we're just looking at correlation. So this has been a brief introduction to bivariate data, two variable data, looking at scatter plots and correlation.